here. And all right, so everybody, welcome to those who are here, and then for all of you who are watching the recording, thank you for being here. I am going to start sharing my screen so everybody can see here. We are going to be going over the chapter 20, extending ggplot2, which is the 20th chapter from the ggplot2 book. My name is Gabby, and I'm gonna be walking you through this chapter today. So let's begin. This is a very, like I was saying before, it's a very well organized chapter. It essentially, and apologies for not going through the notes. I didn't have any time to modify them, but they're not really good. They are just, there's more information in the book, so I'm gonna go over the book a little fast today. So I'm sorry about that, but the notes are not the best, but the book is, the chapter is. So essentially what we're gonna learn in this chapter is how can we modify and create new themes, new stats, new geoms, new cohorts or coordinates, new scales, new positions, and new facets in ggplot. So this is a very, I guess if you are into creating your own themes or positions or scales, even color palettes, then this is a chapter for you. It's a little advanced, but it's full of like very important things that we can actually learn a lot from. So let's go over this. So let's start with the themes. So how do you create a new theme, or how do you modify an already existing theme? So this is the easiest way, or the easiest thing to modify in ggplot. So that's why we're starting with this one. So essentially, let's focus on theme minimal. Imagine that what you want to do is start with this theme, but then change a few things. So imagine, for example, that you want to add elements to it, like, for example, let me see. So this is the theme minimal. This is how it would look like if you have a graph. But imagine if what you want to do now is every time you put this theme, or you use your new theme, instead of having like the white or transparent background, you have a gray background. That's what you want to do. Or you want, every time you use your new theme, instead of not having the axis lines, you now want it to have the axis lines, but you want to preserve the entire design of the theme minimal. Okay, let me just take a look at the chat, because I think there was something here. Okay, so let's see how you would do that. So again, we're starting with theme minimal. So we are going to start a function to modify this theme minimal. This is how it looks like, right? This is our theme minimal. This is exactly some of the things that it already has. We are going to do, or to use this replace operator in order to replace some of the things that the theme minimal already has. And that is the key here. So we start with the basic things that it has that you want to keep. For example, if you wanted to start it with your font size is going to be 11 by default, that's what you add here. If you want to do like a family, this is going to be the font that you want to use. If you wanted to start with a specific font, then that's what you put in here. And then you replace whatever it is that you want to replace by using the theme. So for example, let's see if you wanted to do a new theme called theme background, starting again with your theme minimal. So you create your theme background function in order to use that one, right? So you can start your script with this and then just use theme background every time you do your plots. So to do that, you start your function saying, this is the argument that I want to focus on, background equals white, and then a bunch of other arguments that I'm not really sure what they're going to be, but I'm going to include others. You start by saying theme minimal. So we're going to start with the theme minimal, all the arguments that it has by default. And then what I want to do is replace the following ones that are going to be inside the theme. So it's going to be, for example, for your plot background, what you want to do is you want to change the feel of your background. So in this case, it can be white, or you can choose another color, right? That's going to be one of the arguments that you're going to give to your function. It can also be the color, etc. And then always remember, every time you're doing this with your themes, you're modifying a theme, end it with complete equals true. That way, every time someone uses the theme background, it's going to use all the arguments that are already in theme minimal. So this is like a good practice to do. Remember to always finish your new theme by putting complete equals true. So let's see how this would look like. So let's say we have a random example using the MPG data. We have seen that so many times. So this is what it would look like using the theme minimal. And we're only modifying the base size. I guess this would be the font size, if I'm not mistaken, or maybe the let's see, base size. Yeah, I think that's gonna be the yeah, I think that's for the access titles. Okay, so that's how it's looking normally. But now what you want to do is use your theme background, because you don't want to use your theme minimal. You want to use your own theme. And in here, you can include all the other arguments that you wanted to change that you said in the beginning. So you said you wanted to use background and everything else. And that includes obviously the base size, because that is included here, right? And then background grade 70. And then what it's going to use in this case is your theme minimal as a base, and then with all the other modifications that you did. So imagine, for example, okay, so where do you put that? There are different ways of doing this. I think that it depends. I think it depends, because what John would say, I think, is he would say create your own personal package and then create your theme Gabby and put it in your package, and then every time you call it, it's inside your personal package. But let's say you don't know how to create your own personal package. Another option could be, when you're writing your code, have a dedicated folder with all your functions, and that function could be there, or you can have like your ggplot functions or something and then have them there. And then at the beginning of the script that you want, you just source that that script, and then it's ready to be used with any script that you're gonna, with any thing that you're gonna do in that script, because you already sourced it. Another thing is, if it's gonna be just something very, very simple, then just put it at the beginning of your script. So where to put it, I think it depends on that. So yeah, it depends. What?
I'll jump in. Sorry, I'm kind of recovering from being sick last week, so my voice may be a little raspy, but I think the one of the like those are important points about like where to put it and everything. Like the biggest question that I have with this, and this is more of like an organization question, would be like, okay, do I create a separate package that just contains all of the themes? And then like people that I work with, they just pull that package down when we're creating a project or something. Or with the individual packages that we have for our projects, do we have those themes just transferred over to every single package? Like we've gone back and forth with that because sometimes different packages for projects need different theme options. And so, but at the same time, there's also that like being able to track any changes for those themes. And so it would be easier just to create like an overall themes package. So I don't think there's a right answer to it. It's just like, I don't know what's worked with other people and was just like, That's the one thing that I find confusing about like creating that like extension part, like creating theme extensions.
Yeah, I think you just answered your question. I honestly think that's a little user dependent. I think different organizations are gonna be working differently. You can ask that question in the general chat questions that we have here in our data science or data science learning community. I think that would be the best place to put your question. I think it depends on what's easier for you. May not be the best way for another organization to work. So I think you based on what you said, you just answered your question. So yeah, it's whatever it's easier. Yeah, and there are so many ways to go about it, right? So yeah. Okay, I'm gonna keep going because I don't have a lot of time today. But essentially, this is the way to modify your themes. Just remember the replace operator and then the complete true. And it can save you a lot of time if you need to do a modification on a theme. But to be honest, there are so many themes already done that, yeah, I don't know. All right, so then let's move on. This is the complete thing that I was talking about. Okay, now let's define theme elements. This is, I'm gonna have to jump this one. Yeah, let's talk about new stats. I think that with theme, let's just focus on this part, and then there are other specific things, but I'm not gonna have a lot of time to go through them. So let's go to new stats. So let's imagine for a second that what you want to do is create a new stats function. So what does that mean? It means, for example, that you have here your points, right? This is a scatter plot, but you create a function or you create a new stat in ggplot that is what it's going to do is create a convex polygon. Yeah, you want to create a new polygon around all your points so that it captures all your external points. So you don't want to, let's say there's not another package that does this. There is one for this example, but this is just, let's imagine that there isn't. And then how would you go about doing this? So it's not a new geom, right? You're not creating a new geom. It's not, it's essentially a new stats so that it's going to help you modify in a way the way your data is displayed. So let's see an example of how you would do this. It essentially has two steps. We saw in last week with Derek, we learned about this ggplot2 or ggplot2, depends on how you say it, how you prefer, this ggplot2 function. So let's just remember what that is. So it essentially, what it's doing is you are modifying the most basic parts about a ggplot. So you're going to the base or the most basic part of ggplot, and then you are modifying them. So we saw this with Derek, but let's just remember how this works. So this ggplot2, we're gonna use it with all the other ones except with themes, but we're gonna use it with all the other ones in order to learn how to modify something that is already existing. So in this case, it's gonna be a stat. So remember that with ggplot, you start with two arguments. First, it's gonna be the name of your new stat, in this case, right? The new thing that you wanna create. So it's called stat c hull. So that's what you put inside quotes. That's the first argument. That's how you always start your ggplot2. And then the thing that you're going to modify that is going to inherit everything from. So in this case, it's a new stat, right? This could be a new color palette. This could be a new geom. This could be a new facet, etc. So that's how you start. And then you start to modify your function. So in this case, when you want to modify a stat, this is where it gets a little tricky. So you want to focus on 3 arguments: compute layer, compute panel, and compute group. This is the only one that's a little bit more complicated than the other. So each one is going to be doing something to the data that you have. So for example, the compute layer, it's going to split the data set by the panel column, and it's called compute panel. It reassembles all your results, which is what you want. And then the complete panel, which comes afterwards, is going to split the panel data by the group column, and it's going to reassemble all your results, which is what you want. However, as a general rule, it is better to begin by modifying your compute group only and see if the performance is adequate. If it doesn't do what you want to do, then you can go ahead and modify your compute layer and your compute panel. So let's see an example of how this would work. So we start with the compute group here inside your function, and then you say to that function, you're only going to modify data and scales. So your data is going to be all your points, right? Everything that you want to give this thing. And then you're going to use this chal function that is from the grdevices package. And you're going to create from your X and your Y that convex polygon around it. You have your required aesthetics that are X and Y, and that is what goes inside your ggplot2 function. So that's going to say, okay, so this is going to be my new stats. But then what you want to do is you have to give the user a way to use your stats chal. So then that's when you modify your stats chal function. So that's the second part. First, you do, or you create your ggplot2 object or your ggplot2 thing that you want to modify, and then you modify your entire function. So that's the second part. So how do you do that? Again, that's chal, but look at the way it's written, right? Like capital S and capital C. And now you're going to create your ggplot function that your user is going to use. So the name is similar, but obviously, just so that you know that they are sort of related, right? So this is going to be stat_chal. That's what you're going to use in your ggplot, right, to modify your thing. So again, you're going to include all the different arguments that you want inside your function. This can be, if you don't know, then just put your 3 dots, but then, you know, we've seen that before. I think Kaya was the one that walked us through through how to modify these functions. But anyway, inside your function, you're going to put a layer, because everything works in ggplot, it's in layers. And this is where you modify your stat. The rest is exactly the same. You're not modifying really anything. These are all arguments that usually are inside a stat function. But this is where you put your ggplot2 or your ggproto, however you want it, because it's prototype. So I guess it's ggproto. Your ggproto function. You put it here because that's the thing that you want to modify. So now you're ready to just use it. So let's see an example here. Again, with all the arguments that you previously predefined, right? Like the field, the color, these are all arguments that you can, because they're inside here, right? So these are all arguments that you can modify. That they're also inside here, and then, so that's how you work. So this is your stats chal. You can either, because the chal is using like a polygon, this is why you can define it as not having a fill, because otherwise everything would be black inside here, but just the lines around it, right? Like, which is the color. And then this is why this one, because you're defining it by color above in your aesthetics, then that's why each one of them is a different color, but then the field is empty. So then they are see-through, right? That's what you want. So these are 2 different ways of using that. This is super useful And I think this is just a very simple example because things can get super complicated with stats. All right. You can also modify different parameters and the data that you want to do inside your stat. So that is a little bit more that I'm not going to get into those details, but just know that it's something that you can do. The book even doesn't go into too much detail about this, but you can modify, like, for example, if you want to create that stat hole, but instead of using it with discrete or continuous variables, you want to use it with dates, for example. Or if it's a geom that is only defined for continuous variables, now you want to define it for discrete functions or a stat specifically for a specific type of data. That's when you do all of these parts right here. But anyway, I'm just going to jump to geoms because otherwise we're not going to finish today. So we saw themes and we saw how to modify stats. So how do we modify geoms? So geoms are, remember that geoms are if you have points, if you have a polygon, if you have a violin, if you have a box plot, those are geoms, right? So how do you create a new geom if you have to? Again, you start with your ggplot2 or your ggproto or your ggproto prototype, right? So then we're going to call this geom polygon hollow, which is essentially the one we did before with the convex polygon. But this is an exercise, so this is the new geom that we're going to create. So it can be a stats, or you can create it as a new geom because it's a new shape that you're going to see, right? And this is why it's called geom C-hole, because it's a new geom, right? Okay. Okay, so let's modify the ggproto. We start with the name that you used here, always, and then you modify the part that you wanted to inherit from, which in this case is going to be a geom polygon because it's a polygon. So you wanted to inherit everything from there except a few modifications that you want to do. And those modifications are going to be that it's going to have a color that you, in this case, are going to set as black, but that one can change. And then the field is always, or by default, it's going to be NA. And then you're including other aesthetics that you want to have as default. Now, let's create our ggplot geom, which again, see how this is written, geom polygon hollow. And then your ggplot function is going to be called geom C-hole. Again, just remember that one thing and the other one are related, so you can use the same names like we used before, or you can use different names. That's up to you. Just remember that these two are going to be related in some way. So comment it out. So essentially what you're doing is you're creating your function with all of these arguments and leaving, as always, the ellipses in the end because you're going to include many, many more, or you could include many, many more. And the thing that you're modifying, the only thing that you're modifying is your geom by using the ggproto function that you created before. The rest stays exactly the same because you're not modifying anything else. You could, but in this case, you're not. So then this is how it would look like, right? It's your new geom, and this is what it looks like. Again, you can also modify your geom data, which is going to be is visually equivalent to an existing geom, but it's going to accept data in different formats. So the way that they're working here is that they're changing the data to be in, I think it's in radians, if I'm not mistaken. We'll create a geom re-implements the functionality of geoms with regards to some data.
Yeah, I think it is in radians by default.
In radians, yeah. So that's why it looks like that, because you're going to change the way your data looks like. So anyway, Again, you begin with your ggproto object. GM Spike is the name, and then you're gonna base this on GM segment. Again, we're modifying the data that's gonna be inside your new GM. So then you specify the required aesthetics, which is gonna be your X and your Y, and then you need an angle and a radius, because remember, this is gonna be for data that it's gonna be in radians, or that it's gonna be like in a circular coordinate system. I guess that's the best way to describe this. And then this is how your data is going to be transformed before any drawing takes place. So this is the thing that you want to modify here, right? Because you're doing this with dates instead of continuous data, or you're using it in this case with radians or something like that. And then again, after your ggproto object is created, you just change the function. And the only thing that you're changing here is, again, your GM, because you're using your GM Spike ggproto. And now you can use it in your plots. So remember, it's going to require an angle and a radius, so that's going to be in your data frame. So you start your ggplot with your aesthetics, your X and your Y, and all the data that you want. And inside your GM Spike, you are specifying, instead of just your X and Y like we saw before, right? You're going to include the angle and the radius, which is in your data frame, and which you included here in your GM Spike ggproto object. And then that's how it's going to look like. All right. And then it has a way of how you can combine multiple GMs. I'm going to skip this part so that we can learn the others, but I encourage you to learn how to do this in case you want to combine different GMs in one of your functions. You want to modify multiple GMs in one function. New coordinates, I think this is, they don't provide a lot of information here. They say that they already gave a few examples in chapter 15 and chapter 6. And then in the case study too, in chapter 21, which is next week, but they don't go into too much detail on how to do this. To be honest with you, I don't know. I feel like they already have all the coordinate systems that we could want. But again, you never know, right? I haven't really thought about using a new coordinate system.
Yeah, I had so much trouble getting my head around the existing chord things. Like, that chapter was tough enough, and I can't imagine wanting to add additional ones. But it's good to know you can.
It's good. Yeah, you can modify everything here. I think that's the lesson here. But yeah, how you go ahead and think about a new coordinate system, I don't know. I can't wrap my head around it. But anyway, let's talk about scales. So this is going to be color, for example. This is going to be feel. This is going to be anything that has to do with a scale, field, scale, color, scale continuous, scale discrete, whatever. All of those, this is how you modify them. Let's start with a very simple case. So let's say we want to modify the scale fill function so that when we create our violins, we are including this scale fill random. Imagine if you want to create, for example, your own color palettes, your own color palettes. So you start, let's start with this. Let's create random colors function, which essentially what it's going to do is it's going to include all the colors that you want. So this colors function, what we're saying is we want distinct colors, n number of colors, and we want them replaced so that it's not the same color repeated. And then by sample, we're saying sample from this, right? So then give me all of these colors. So that's going to be your random colors function. Then we are going to write our scale fill random function. So this is your personal function that you want to do, your personal color scale that you want to do, scale fill R4DS, scale fill Gabby, scale fill whatever, right? So let's do that. Let's start by creating our function with a bunch of arguments. So we use the ellipses, but we're going to focus on the field aesthetics. That is essentially what we want to focus here. Yes. Yeah, exactly. Oh my God, I know. It's like, oh my God, yes. This is the one that I modify the most, themes on this one. But anyway, so here we use our discrete scale, but look at this. If you wanted your continuous, because you wanted to use this with continuous variable, then you would have to do continuous scale, right? Or use them both. But anyway, for this simple step, discrete scale, your aesthetics remain the same, but now your scale name is going to be random because it's going to be scale fill random, right? Scale fill Gabby, and then the scale name would be here, Gabby. Okay. And then your palette is going to use the random colors that you defined previously. So then you start with your ggplot, you create your violins, and then you use your scale fill random. And then this is how it looks like. So this is the simplest way to modify a scale fill. But again, you can have scale width continuous, scale color, whatever you want to do, scale, what other scales there are? There are so many. Anyway, this is just an example. And then we have two last ones to work on, which is going to be position and facet. The positions, let's see an example just so that you can get an idea of what we're going to do. This is, let's say, if we want to have position jitter or jitter. Sorry, my accent sometimes it's really bad. Position jitter. So this is what your points would look like, right? You don't want them to be one on top of the other if it's the same one. So you want them to be a little off one from the other one, like a little off scale. So this is what you would look like. But now imagine if what you want to do is that same jitter, but normalized. So with a mean of 0 and a standard deviation of 1. That's exactly what we want to create right now. It's a new position. It's a new way of positioning your data, which is going to be essentially inside this position argument. So how do we do that? This is just, like I said, an example. And yeah, there are a bunch of ways to do this. Again, we start by creating your the way you want to transform the data. So that's, let's call it normal transformer. And this is going to be a function that accepts x and a standard deviation, because what you want is, again, centered at 0 and one standard deviation off. So this is going to be your function. Again, we're just normalizing the data. So when we call that normal transformer, inside our position jitter normal ggplot2, it's essentially going to use that function to modify the position, which is what we are saying here. So again, we're going to modify our ggplot2. We're going to call it position jitter normal, because that's, I don't know, whatever random name you want to give it, right? So we start with that, and then it's going to inherit from anything position. So all the arguments in position, it's going to essentially copy them, and you're only going to modify a few things from that class. So we need an X and a Y position aesthetic. So those are your required aesthetics. And then you're going to use the set of params to say exactly what we want from the data. So how it's going to look like. And then when you're computing the layer, which is the third one, so you start with your required aesthetics, the set of parameters, and then the compute layer. this is where you're going to use your normal transformer function. So your compute layer, this is like where the magic happens. It's going to be a function that accepts data, parameters, and a panel. So it's going to construct or modify the x and the y by using your normal transformer and function. And obviously you're giving it an x and a standard deviation, and then a y for your y transformer and a standard deviation. And then you're going to include the transform position by saying how it's going to return the transformed data. So you want your data, your trans x, which is going to use the x transformer, which is here, and your trans y, which is going to use your y transformer, which you defined previously. And that is essentially your Gogo Proto. So then what we want to do is we want to create our position jitter normal argument, I suppose. So how do we do that? We create a function that's going to use, by default, these values is that the SDX, which is going to be, that it comes from this. These are your set of parameters, right? Your SDX and your SDY, which is essentially comes from here. Those are your parameters. And you're going to give them some values to start with. And then you modify your, so you use the Gogo Proto function to modify the position jitter normal. Oh, no. Sorry. This is, I'm so sorry. I'm confusing everyone right now. This is the long way of doing the Gogo Proto. This is the short way of doing modifying the Gogo Proto function by giving it instantly to the position jitter normal. I am so sorry. So this is another way that you can do, like you start with the Gogo Proto function, all of this, and then you create your position jitter normal, or you do everything in one step, which would be by including the ggplot2 inside your position jitter normal. Sorry about that. Anyway, yeah. So this is what you are doing. So this would be, I'm so sorry. This is creating so much confusion here. So you start by modifying your position jitter normal. And then to keep things very simple, you just include that thing that you just modified. You put it inside the position jitter normal here in another ggplot2 so that it becomes a super simple function that you're modifying instead of having it the other way that we were seeing by having all of this. It becomes easier, I guess. I'm so sorry. That was so confusing. Okay, and then you're ready to use it, because remember that this is going to be an argument that it's inside a geom, right? So then this is why we take this extra step. Anyway, and that's how it looks like. Yeah, it is. All right, and now the last one, the new facets. So with the new facets, imagine if you want to divide your data using a new way of grouping your variable. So we usually have the two facets, which are facet wrap and facet, what's the other facet? Facet wrap and facet, I forgot the other facet.
Facet grid.
Facet grid, that's right. Facet grid and facet wrap. So imagine that you want to do a facet scatter. This is the new way that you want to organize your variables inside your graph. You can create, I think this is easier for me to visualize other than the new coordinate system, because yeah, if you want to use them grouped by a certain way, so then you want to create like 4 panels inside your graph, for example, or if you want to create, I'm pretty sure you've seen it, but this facet where you have like by states, by the different US states. So that's a different way that you want to organize your data so that the position is inside each one of the US states. Or if you want to create, what other facet you would want to have? Look like I don't know, like an animal or something, right? Like, so you have all your different facets or your different little graphs in the shape of an animal or something. That's another way of looking at this. So how do we do this? How do we create a new facet ggplot function? So again, we start with defining a new compute layout and or a new map data. So the compute layout method receives the original data set and creates a layout specification. So it's going to be a data frame with one row per panel that indicates where each panel falls on the grid, along with information about which axis limits should be free and which should be fixed. So that's a compute layout. Like, it's how does the layout look like? And then the map data method receives this layout specification, and the original data is the input, and then attaches a panel column to it, which is used to assign each row in the data frame to one of the panels in the layout. So these are the two different functions that we are gonna be working with. Okay. So let's start by creating a new ggproto object. We're gonna call it facet scatter. So that's the first argument that we're gonna put inside quotes, and then we're gonna say this is going to inherit from facet wrap. This is already a subclass or a class that already exists, and you're gonna just modify it a little bit in your ggproto. So you start again with your parameters, and you're saying, I want my data, and I want all of my parameters as such. And then you're going to do the compute layout that we saw here. So this is going to change the layout, right? Okay, so how is it going to look like now? This is a function that accepts data and your parameters. So it's going to create a data frame with one column per faceting variable and one row for each possible combination of values. So one row per panel, right? Like, this is the layout of how your data is going to look like. So for that, we're going to say, this is how my panels are going to look like. Combine these variables, which are going to be my data, my environment, which is going to be from my parameters, my plot environment, and then all the variables that you want are going to come from your parameters too. And you're going to say drop false. So then this is going to be the first thing inside your compute layout that you're going to modify. So this is essentially going to tell ggplot, right? Like, what you want to do is one column per facet and one row for each possible combination of values. Okay, and then you're going to create a data frame with columns for row and col. So by that, you're going to use the locations. You're going to create a new object called location. You're going to expand your grid by saying my rows are going to come from 1 to all the rows inside my parameters. Then my column is going to be from 1 to all my from 1 to all the columns that are inside my parameters. You're going to shuffle, create another object that's called shuffle, which is going to randomly sample a subset of the locations by your locations and your panel. And then you're going to assign each panel a location. So you're going to say, my panel is going to be my panel identifier. Then you're going to say how many rows you have for each panel, how many columns you have for each panel. And then your X and Y axis scales are going to be fixed. That's what the 1L means. And then bind those together, your layout and your panels, in order to have the resulting layout. And this is more or less what the output is going to look like for all your layout specifications. So you have 1, 2, 3, 4, 15 panels. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Those are all your panels. Rows, you're going to have obviously however many rows. In this case, we have 1, 2, 3, 4, 5 rows. Then your columns, in this case, you can have 1, 2, 3, 4, 5, 6. Because in the middle here, there's another one too. So those are the numbers that you see here in your column. And then the scale for X and Y, we said that it's going to be the same one. We're not modifying the scales in any of your data sets. And then this is the corresponding manufacturer, which in this case is going to be what appears in this panel, right? Because that's how you are dividing your data in. You're using, in this case, the manufacturer, but this could be whatever other column you have. This could be another thing is in the MPG. You can have it by another has, I think, gears, number of gears. That could also be another one, right? Like how many gears it has, like cylinders, etc. Yeah. So then, in this case, that is the variable that you want to use to divide your data into. And now we write the facet scatter. So this thing is the most complicated one. This creating these ggplot2 objects, it's the most complicated part of all of them. Because then the function is actually super easy to create. It's the easiest part, I think. You're gonna say that basically what you want to do is this facets part. The rest is just the same for any facet. But this is where it's going to go, your ggplot2. Again, inside your function, your facet scatter, that's your ggplot object. And the only thing that changes here is your facet. Now, this thing inside, I do not understand, you guys. I don't know what Erlang is a package I understand. This automate, I have no idea what's happening in here. To be honest with you, I honestly don't know what's happening here. But this is the thing that you want to modify in your facet. The rest stays the same. And then that's essentially what you're modifying. So this is going to be the variables, the number of rows and columns, because that's essentially what you said here that you wanted to modify, right? And then these are your panels. No, where is it? It is, yeah, I guess it's there. This is exactly because you didn't modify the scales. So then, yeah, I guess that's how it looks like. And that is it. Oh my gosh, I'm so late for the other thing that I need to do, but I'm so sorry. I was just running here and going through this really, really fast. So like I said, the book is really well organized, but unfortunately, some things they're not explaining in as much detail as I would like. But nonetheless, I think it's one of the best chapters in the book. So that's it. I'm gonna write end.